Rita Levi Montalcini was born in 1909 in Italy as the daughter of Italian Jews. She was discouraged from entering college. Her father believed that a professional career would interfere with her duties as a wife and a mother, and she resented the fact that she went to a girls' school that prepared her for marriage and not for university. She knew she wanted to be a doctor, and at the age of 20 realized that she could not adjust to the feminine roles her father thought of, and asked to engage in a professional career. Her father agreed to support her. In the 8 months before she started medical school, she taught herself Greek, Latin, and math, and graduated in 1936 from the University of Turin. She began advanced degrees in neuroscience and psych, unsure if she wanted to pursue research or to become a doctor. She focused on histology, staining nerve cells and studying the structure of cells and nerve cell growth. However, in 1938, Mussolini issued the Manifesto of Race, which stripped her as an Italian Jew of her Italian citizenship and banned her from a professional career. She withdrew from the university and accepted an invitation to an Institute for Neurological Research in Brussels in 1939. She returned to Italy that same year, fearing a German takeover of Belgium. Bombing in 1941 caused her family to flee under a false name to a cottage outside of Turin. Her family fled again to Florence when Germany occupied Italy from 1943 to 1945. Throughout the war, she continued her university study of developing nervous systems in chick embryos. She studied embryos she got from local farmers and warmed in a home incubator in the bedroom of her house. When bombs fell, she moved her microscope and slides to the basement. She was inspired by the research of the American Dr. Hamburger at the University of Washington in St. Louis. Hamburger thought that the specialization of nerve cells was dependent on their destination, so he removed the limbs of developing chick embryos to see how that affected that growth and specialization of nerve cells that would otherwise go to the amputated limb. He concluded that an organizing factor that was contained in the limb could not communicate with the nerve cells, so the nerve cells never grew from the spinal cord and specialized. But Levi Montalcini believed that the reason fewer nerve cells grew where that limb should be was because they were missing a nutrient that was produced by the limb. She believed that nerve cell specialization still happened, but that the cells died because they did not receive a nutrient growth factor. Outside of that research, she also observed cell death before it was given the name apoptosis in the 70s. Her research couldn't be published in Italian journals because she was Jewish. It was published in Belgian and Vatican journals in the 1940s, and then she moved to the US where she was invited to do joint research with Dr. Hamburger in 1947. At the University of Washington, she looked at slides of chick embryos at different stages of development and observed the way nerve cells traveled during development. She now tried to find that growth factor that she had guessed at in her research. She implanted a tumor cell line, sarcoma 180, into chick embryos, noticing that once that tumor was implanted, nerve cell specialization would speed up and large numbers of nerve fibers would be created. Alongside Dr. Stanley Cohen, she worked to isolate that nerve growth factor protein subunit from the tumor. She added snake venom phosphodiesterase to rule out RNA and DNA factors and discovered that not only did the snake venom itself contain the factor, nerve growth factor would also be produced in the salivary glands of mice. To conduct her research, she combined neuroanatomy, embryology, and biochemistry. The next questions that were tackled by both Levi Montalcini and biologists at large included describing more of these growth-promoting agents that worked on different cells. For example, epidermal growth factor, which was discovered by Dr. Cohen, plays a central role in breast cancer. Nerve growth factor has now been shown to play a role in memory, learning, and nerve regeneration. Growth factors play a role in preventing neurodegenerative diseases and modulating pain, depression, and anxiety. The more active these brain cells become, the more these kinds of molecules are produced. So the question becomes, will cognitive activity, which elevates nerve growth factor in the brain, prevent degeneration? In the later years, she turned to studying NGF in immune and endocrine systems. As part of her scientific career, Montalcini found herself involved in social work and became a public figure. She established the Institute of Cell Biology in Rome and founded the European Brain Research Institute in 2002. She was the first woman to receive the Max Weinstein Award given by the United Cerebral Palsy Association, and she won the Nobel Prize in the 80s. She was appointed a senator for life for her outstanding contributions to science. She did not believe in politics, but believed in democracy as a method of progress. While a senator, she fought far-right Italian politicians over science research budget cuts well into her 90s. She was the ambassador to the Food and Agriculture Organization of the UN, combating world hunger, and started the Levi Montalcini nonprofit foundation in memory of her father, which mentors, counsels, and provides grants to students, and established the Rita Levi Montalcini Foundation, which provides research resources to African women who are pursuing science fields. She believed that if women are given instruction and tools, they can conduct science as well as and better than men. She continued to visit her lab well past her 100th birthday and died in Rome at the age of 103. I don't think that there is any correct or wrong way to deal with personal discrimination. Levi Montalcini's attitude towards persecution was that it spurred her on. She said that if I had not been discriminated against or had not suffered persecution, I would never have received the Nobel Prize. Her work has been monumentous, and she's considered to have revolutionized the study of neurodevelopment.